welcome to another episode of Everypoint Academy. And in this episode, we'll be looking into how to convert denary to hexadecimal. So, when you are converting denary to hexadecimal, it is very similar to converting denary to binary. But in binary, we divide by 2. Instead of 2, what we do is we divide the numbers by 16. All right. So before we start this, I will take an example from converting denary to binary first, and then let's look in how to convert denary to hexadecimal. All right. Uh, for this example, I'll be taking 54. 54, right? We can divide by 2. Then we get let's see, 27 and 0 balance, divided by 2, 16 and 1 balance, divided by, sorry, 13 and 1 balance, divided by 2, 6 and 1 balance, divided by 2, 3 and 1 balance, and divided by 2, 1 and 1 balance. So, sorry, 6 divided by 2 is 3 and no balance. So we get 1, 1, 0, 1, 1, 0. 54 denary is equal to 1, 1, 0, 1, 1, 0 in binary. Alright, now we know how, again I gave you a refresher on how to convert denary to binary. Now, before we diving into the converting binary to denary part, denary to hexadecimal part, we need to know one thing. We need to know the 16 times table. Alright, so when we are, what we should know is we shouldn't like, uh, like we shouldn't um, keep it in our memory, but I will show you a short method. Also, once we are complete with the converting the binary to hexadecimal and hexadecimal to binary part, I will be showing you an alternative method in another episode, right? So stay tuned for that one. But this is the standard straightforward way of converting denary to hexadecimal. All right. So the first thing you need to know is the like I said, the multiplication table of the uh, 16 times. So let's start 0, 1, 2. We start from 0, right? 3, 4, 5, 6, 7, 8, 9. All right. So this is I will show you how I used to remember the 16 times table. Actually, I don't remember it. I just calculate it, right? If you are good in remembering, you can remember it. Otherwise, you can calculate it on the spot, right? So 16 times 0 is 0. 1 times 16 is 16. 16 times 2. Actually, what I'm doing is I'll be yeah, 16 times 2 is uh, like in 16 times 2 is 32, right? And then what I do is 16 times 3, I don't remember it. So what I do is I add 1 and 2 in order to get 3. Do you understand? Like 16 times 1 plus 16 times 2 is equal to 16 times 3. So 1 plus 2 we get 3. So basically what I do is I add them. We get 8 and 48, right? Then 2 times 2 is 4, so I can get 32, 64. That is the binary. If you can remember, and we can get 8. Similarly, we can 64 times 2 is 128. That we remember in the binary conversions, right? So that we know. And then 16 times 5. All right. So 16 times 5. This is a way that I use personally to calculate multiply by 5, right? So instead of multiplying by 5, what I do is I divide by 2, right? Instead of multiplying by 5, I divide by 2. Basically, any value, for example, 32,324, instead of multiplying by 5, right? What I'll be doing is I'll be dividing by 2. 324 divided by 2 is 16, 1, 6, 2, and we get a point 0, right? So remove the 0, remove the decimal point, you get 1620, right? You should always take one decimal point. If it was a odd number, for example, let's say 300, I'm not sure I'm taking 300, but let me remove this and let's put 555. 555 divided by 2 is, we get 2, carry the 1, 15 is 7, carry the 1, 15 is divided by 2, we get 7, carry the 1. That 1 also should be divided and we get 0.5. Without the decimal point, we get 2775, right? That is, you should, what happens here is 5 is equal to 10 divided by 2, right? 5 is equal to 10 divided by 2. So this is not computer science, this is actually maths, right? 5 is equal to 10 divided by 2. So anything, what I'm doing is I divide by 2, right? And multiply by 10. So that is how I get the values faster without multiplying. For example, over here, 5 times 4 is 20, 0 carry the 2, 2 times 5 is 10, so 2 carry the 1, 3 times 5 is 15, 15 plus 1 is 16. Right, so again it is your choice. Now in this case, let me we just sidetrack from our lesson for a bit. uh, it always works, right? Like I said, we divide by 2 and multiply by 10. So 16 divided by 2 is 8, multiplied by 10 is 80, right? Now what I'm doing is I get 5 plus 1. 5 plus 1 is I get here 0 plus 6 is 6, 8 plus 1 we get 96, right? We can do 5 plus 2 also similarly, right? 0 plus 2 is 0 plus 2 is 2, 9, 8 plus 3 is 11, 112, right? 9 is 5 plus 4, 5 plus 4 we get 4, right? Sorry, 0 plus 4 we get 4, and 8 plus 16 we get 14. So that is the value for 9. Now we have the all the values that we need. Now let's start converting, right? So 54 divided by 16. So what I do is we have to get the closest lower value, right? Not the closest lower value we get is 48 in this case. So we get put 48 over here and we have to get the balance. 54 minus 48. 54. Sorry, I made a mistake. Sorry. Yeah. All right. So 54 divided by 16, we get 3, right? We get 3. So we put 3 over here, right? 3 times 16 is 48. We subtract and get the balance. So 4 minus 14 minus 8 we get 6, and here we don't have 10, so 3 and 6 balance we say. So this is, and then we take from bottom to the top and we get 54 is equal to 36 in hexadecimal, right? Not 36, we don't call it 36, we say 36 in hexadecimal, right? So let's have a look at another one. Here, because I don't want to erase the board, what I'll do is I'll just because I don't want to lose the multiplication table that we wrote, I'll just erase them. All right. Now, next one we have, I'll take, let's say 100, right? I want 100. I want to convert 100. And then let's say I want to convert 500 and then 999, right? This is, and then I'll just put a few more values like uh, 8,888 and 54,321. I just want to put some larger values because this is pretty, since the number of digits are larger, the base is larger in the hexadecimals, the space taken or the calculation is very short, right? So for example, 100. So we have to get the closest lower value. So we get 96 over here. So 96 is 6. So 100 divided by 16, we get 6. And how much balance? 100 minus 96, we get 4, right? 4 balance. So 100 in Denary is equal to 64 in hexadecimal. All right. Now let's look at how to convert 500 into hexadecimal. So we have 16, we divide by 16. So 15 we can divide by 16. So we can, let's see, we get 48. We get 48. So we have 3. So 50 minus 48, we get 2. So we get 20, right? So 20 divided by 16. So we get 16 over here. So 20 divided by 16, we get 1. And 20 minus 16, 20 minus 16, we get um how much? 20 minus 16 is 4, right? All right. Then now we have to divide 31 by 16. So 31 divided by 16, we get uh, only 1, right? And then 31 minus 16, 31 minus 16, we get 15, right? All right. So we have 15 here. Now, this thing, when we cannot write, we cannot say that 500 denary is equal to 1154. We cannot say that is wrong, because this 15 is representing only one digit, not two, right? So instead, like if you can remember, when I was introducing the number systems, we came up with I showed you a method, an easy method without writing the numbers to like to find the number. So 15 is, so we take our hand, make a fist out of it, and this is 0 or 10 actually, right? 10, 11, 12, 13, 14, 15, right? So we have, so to find 15, we have to have all of 5 fingers up. So let's start. A, right? A is 10, right? 10, A, B, C, D, E, F. So since when we are having 5 fingers up, we get F. So 15 is equal to F, right? So 500 denar is actually equal to 1 F4 in hexadecimal. Is that clear? All right. Next, we have 99 and 99. let's do that one also. 999 divided by 16. So we can find 99. 99 is 96, right? We can have the closest lower value is 96. That means we get 6, right? 99 minus 96, we get 3. And we have to find the for 39 now. 39 we get over here. We have 2, right? So for 62, sorry, 39 minus 32, we get 7 balance, right? And then we divide this by 16 again, right? For 62, with the closest value we can get is 48. So 48 is 3, and then 62 minus 48 is equal to, we get 14, right? So 14. And again, like I said, we 14 is just one value, right? So A, B, C, D, E. So E is 14, right? So E is 14. So we get 3E7. Is that clear? That is the easiest way of remembering this, right? That means we have our hand all the time. We didn't take time like writing it anywhere, right? We have our hand all the time. So A, B, C, D, E, F. That's it. All right. Let's do a little bit more complicated, but it's again very simple, right? The number steps doesn't go be is not as long as binary, but it's a little bit complicated because we are dealing with the 16 times table, right? Again, it's very easy still, right? We divide by 16. So we get 88. For 88, we can get 80, right? The closest below value is 80. So we have 5 here. And then we get 8 balance. 88 minus 80 is 8 balance. So here, 88 again, right? So again, 5 and again we get an 8 balance. 88, 5 and another 8 balance, right? So we get an 8 balance. And now we divide this by 16. Right, so for this one we get 48, which is 3. 5 minus 55 minus 48, we get 7. So 75. For 75 we get 64, right? For 64 we get 4, and then 75 minus 64 is 11. 11 balance, and now we can have another step. So 16. 34 is actually, we get 2 here, and we get 34 minus 32, we get 2 balance. So 2, 2, and for 11 we get A, B. 2, 2, B8. Is that clear? And also make sure that you write your B like a B, not like an 8. Alright, so that you might, alright. That is the uh, answer for that one. And then let's have a look at the next one. 54,321. So for 54,321 we divide this by 16. So for 54 we get 3, right? 348 minus 54. 48 minus 54 is 6. For 63 we get again 3, right? 63 minus 48 we get 5 and 1 balance, right? So we get 15. All right, so we get 15 balance over here, right? 15 we can get balance. So here 152, the closest value is 144. So we get 9 here, right? So 152 minus 144 we get 144 we get, let me erase this, and again 144 we get, let's see, 8, right? Yeah, just 8. 81. For 81 we get again 5, and 81 minus 80 we get 81 minus 80 is 1 balance, right? Then divide this by 16. Here we get 32. 32 is 33. 33 minus 1. 33 minus 2. 32 is 1. 19. For 19 we get 1, right? 1, and we get 3 balance. 35. For 35 we get 32, and that means 2. And 35 minus 32 is 3, right? Similarly, we'll be going at this one also. We divide by 16. For 21 we get 1, because it's divided, we get 16, which is 1, right? And then we get 21 minus 16 is 5 balance. For 52 we get 3, right? 3, and 52 we get 3, and 52 minus 48 we get 4, right? And here 13 cannot be divided by 16, so we stop over there, right? Now we get 54,321 denary is equal to 13 is not 2 digits again, it's just 1 digit. So A, B, C, D, right? A, B, C, D. 13 is D. D4331. D431 is 54,321 in hexadecimal. All right. That is it for this episode, and I hope you understood everything that I said. This is again very similar to the binary conversion from denary, but still the difference is we have we are dividing by 16, and there are more digits, and it's a little bit complicated, but it is still straightforward, right? So this is it for this episode, and in the next episode we'll be looking into how to convert hexadecimal to denary. So that is it for this episode, and I'll see you in the next one.